Sweet.
We needed something about a fox, right?
Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Al Williams.
This is episode 216. We'll be talking FETs, FACS, and Electrochemical Fab. This week in the news, we just kicked off the second round of the Hackaday Prize. This is the Assistive Tech Challenge. So if you've got anything that can make the lives of someone who has it hard a little better, this is your chance to enter.
You know, we're really living in a good time for that too, right? I mean, think about 20, 30, 40 years ago to have some sort of specialized tech for your particular issue would have been a big deal. And now, you know, an Arduino in a couple of hours and you can have a lot of different things.
One year, the iDrive-O-Matic won the grand prize, and that was a kind of do-it-yourself adapter to drive around powered wheelchairs. And this is the sort of thing that you can customize it to your exact situation and, you know, make it fit your model of wheelchair and move it around how you want it. And I think that sort of stuff, all 3D printed, of course, that sort of customizability is really fantastic these days.
Well, it's interesting you mentioned that. We did a post, it's been a long time ago now, about a hackerspace here in Galveston that's associated with a hospital. And they actually had a full-time person, and they would help the practitioners, you know, the doctors, the nurses, whatever, to come up with these specialized things that would help particular patients. So if you can make something that fits somebody exactly, which is real easy to do with 3D printing compared to everything else, apparently there's a lot of opportunities to use that in a hospital setting. We probably ought to check in with them and see how they're doing. That's been a few years ago.
And it doesn't always have to be, you know, people who are disabled per se. I think Tom picked a particularly neat example in his write-up announcing this round, which was an old school looking radio for a grandparent with dementia. And so it's got two knobs, right? It's got a volume knob and a turn to advance to the next song knob and a pre-programmed playlist of the person's favorite songs. If you're having kind of early onset dementia, it's a super quality of life feature to be able to listen to music you want to. And, you know, if you have to get through the hurdles of like cell phone technology to just play some damn songs, it could be really a bummer. And this sort of thing makes that easier. And it's just a simple, sweet project too.
Yeah, my mom suffered from that when she was alive. And I actually had a digital assistant at her place of residence. And so I would be able to command it, you know, play music on such and such speaker and have music play for her because that was basically the only way that was going to happen. But we've seen a lot of projects like that. The TV remote controls with like 3 or 4 large buttons. That's a popular one. I remember writing those up a couple of times. Yeah, it's a great thing. And of course, you know, some of us have other disabilities. I'm just not good in a machine shop, but I can run a 3D printer. So that's assistive tech in a way too, right?
Yes. I think we can't open the contest that widely for you, Al. I'm sorry.
Oh, come on.
I did.
It's allowed me to keep 10 fingers, Elliot. So.
Oh, I hear you. It's allowed me to make square corners where I couldn't with the saw.
Correct.
I hear you. Well, let's head on off to the What's That Sound? Drum roll, please.
This is a journey into sound.
What's that sound?
What's that sound?
This week is a drawing week. That means last week we played a sound and asked y'all to identify it. How many people? 63 people wrote in.
Wow.
Of whom 47 had the right answer. Do you want to take a listen to it and see if you can get it?
It was something rotating. So the thing that came to mind, and I'm sure it's not right, but it reminded me of an old Spirit mimeograph. You remember you'd put the stencil on the drum and it kind of had that sound to it. I'm sure that's not right, but that's my guess.
A couple people guessed that. Like someone guessed an old printing press, old copy machines. Barbed wire making machine is the craziest wrong answer, I think. No, it was actually a slide projector.
Huh.
I thought that ka-chuk ka-chuk noise was a dead giveaway.
Yeah, but it sounded very rhythmic, so I was assuming it was something rotating at a constant speed, but it didn't. That usually you didn't hear ka-chunk 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 unless somebody was just pushing through slides, right?
Yeah, I think the person demoing it for the sound sample was just holding the button down or something. Anyway, we had 47 right answers, like I said, which is a lot. And to make a random number up to 47. Okay, well, I'm looking around for a coin and I can't find one, but I'm going to flip a piezo disc. So the side with the crystal on it is going to be heads. That's going to be a 1. And the side that's just the flat brass part is tails. That's going to be a 0.
Only at Hackaday.
And we got 1 for the most significant bit. So what is that? That's 32 so far. Next significant bit, if this is a 1, I have to flip the whole thing again. Oh, son of a... All right, we got to start again. This is the worst method because you have to start again if you get like a 48, which I just did. So, all right, here we go. In the name of fairness, random coin flip. Worst ever. Okay, good. Tails this time. So that's a 0. Here goes for the 16s. Also a 0. And the 8s is a 1. So we got 8 right now. 4s is a 1. So we got 12. 2s is a 0. So we're still on 12. And the last one is a 1. So it's number 13. Congratulations.
13.
Congratulations, 011001 or whatever that was. Which is Mr. SDR. It has to be a slide projector. Congratulations. I'll get in touch with you and get a Hackaday t-shirt out to you. Everyone else, stay tuned for next week and we'll get you a new sound to try out your luck with. So I'd like to start off the hacks this week with a retro tectacular, actually. Dan Maloney wrote this one up, putting pictures on the wire in the 1930s. And this is a story about a super early facsimile machine. And the old school movie is lovely, not the least because it tells the story of someone going out to take a picture of an airplane flying off of a truck or something out in the desert. But the news reporter gets out there with his old speed graphic camera and takes the picture. They develop it. Of course, it's, a 4x5 film negative. He actually hands it down through the slot in the top of the van into the dark room that's inside the van. And the guy develops the film real quick, hands it over to the electronics guy while they're speeding off to the nearest phone pole. And at that point, they have a picture and they run it around this machine. They spool it around, a cylinder. And there's an electric eye. There's a light and it reflects off of it, bounces off to a photo tube, and then this sends the image across the phone lines back to the main office. I love these old school videos because sometimes they just have the best demonstrations of how it works. And this one's no exception. They draw a picture of a car on a wound up cylinder of string, and then they unwind it from one cylinder onto the next as a demo of how this thing sent the pictures across the phone wires. It's almost literal. It's really a shockingly simple demo. But also this technology, granted the wrapping it around a cylinder trick and, kind of slowly advancing along the cylinder isn't exactly the way we raster scan things, but it's pretty darn close. And for this to work back then in the old days with the fedora reporter and his trusty speed graphic, it's pretty amazing. And it's a really neat idea. And it really just, besides being a cool old retro tech and an explanation, it also kind of makes me want to try to replicate the same thing with modern equipment.
I'm always fascinated by how old fax machines really are. And that whole thing reminded me, I don't think it was actually one, but the hams, we used to have a lot of surplus WeFax, which was the Western Electric fax. And they were the big steel cabinet and the same kind of thing, a drum, a photo tube, and the output was a piece of electrolytic paper and an electrode, which of course smelled really bad when it was, tracing the black on it. I actually had one of those. I don't remember why or what I did with it now, but as a kid, I had one that I'd picked up at a ham fest. I don't know whatever happened to it either, so who knows? But, if you look at it, we did an article quite a while back where, even in 1840s, 1850s, there were experiments of sending pictures across wire and later across radio. Jenkins, back in the 20s, So I've always been really interested. You think of that as a I mean, I guess now if you're young, you think of it as an old technology because it's from when, we were younger, but
From the 90s.
you don't think of it as super old. And yet it is actually a super old technology. Funny you mentioned the 90s. We also did the article a while back about FedEx, where FedEx had invested in all this infrastructure to have Zap mail. And by the time they got it out, the fax machines were becoming popular. So Zap mail they were going to have where you go to the FedEx office and say, would you send this to Seattle? And they would fax it to Seattle and the FedEx guy would bring it to the place, right?
Oh, right.
And it was a little more complicated than that because they wanted the big companies to, rent the fax machine from them. But the fax machines weren't Group 2 compatible. And when the Group 2 fax machines became cheap, everybody went, well, I'll just buy a fax machine, right? I'm not going to go to the FedEx office or rent their weird fax machine.
Right.
And if I recall correctly, that's the one where somebody bought all their machines for scrap, hung on to them until the memory crisis, sweated the memory chips off of them and made a fortune. So that's why you never throw anything away.
Yeah, well, I'm not 100% sure. I was looking at this and thinking about the way they must have done it back then, and the news reporter asks for a direct line back to his, central office, wherever he's sending the picture to. And I wonder if they actually had like a literal direct connection, and if this thing was sending literal voltages to represent the different grayscales across the line. And that, of course, you couldn't do today. You'd have to encode it in, amplitude modulation or frequency modulation or something. And actually, with all the funny codecs and bit crushing they do on phone lines these days, you'd be lucky to get that across too. Like, it's not as easy to do this kind of tricks anymore.
Yeah, I'm curious. I doubt that's true. I think the WeFax was FSK. And, as long as you got enough separation, you just need a couple of sharp filters, right? All the old teletype machines had the big 88 millihenry chokes in them for those filters for the mark space. So I don't know if that would have been, it's interesting. You could have had, if you were at a teletype thing, it could have been 60 milliamp loop, like you say.
Yeah.
But I think over a phone line, it might have been still audio. And like I say, I know the WeFax was like that.
It looks like it'd be just super funny to play with. And I could see this as a museum demo that would be really awesome to have scanning in a picture around this like cylindrical spinning thing on one side and sending it to the other. It'd just be charming to see it run.
Well, my pick for this week was from Luke, and it's the Make Your ESP32 Talk Like It's the 80s Again. If you're old enough to remember, which of course a lot of people aren't now, there were all these 80s speech synthesizers that we thought were really high tech in the day. So I have a fondness in my heart for those. And so it was just really interesting. I love the old retro tech, all the stuff that I would have liked to have played with when I was a kid and couldn't afford it. And this was kind of spoke to that. But it was interesting. I had a TRS-80 Model 3, and I had a speech synthesizer card that plugged into the back of it, and it was the same kind of technology where it was just really robotic sounding. So, of course, if you have to ask why you do something, you're in the wrong website. I decided to make a phone answering machine out of all this, so I had coupled it to the phone, and I had the cassette port that would pick the phone hook up and on and off, and it would, basically put a tape recorder that would record. So I went off somewhere for the evening and came back, and it said, oh, you've had, 128 messages or something ridiculous. So I thought, oh, I've got something's wrong. I did something wrong with it. And I shut the thing off. A couple of days later, I see a friend of mine, and he says, what is with your phone? I said, what do you mean? He says, well, I called you, and it kept hooking me up to this wrong number, and there was this terrible sounding guy on the other end of it. And I kept calling to see if I got the number. He had called like 100 times. And heard this speech synthesizer, couldn't make any sense of it. So it kind of reminded me of that. But I just think it's fun to see all this old tech still being taken care of and working and getting it to work with an ESP32, which was probably, 10 times the computer that kind of technology's ever been driven with back in the day. So.
Yeah, I've actually played with the software behind this one. This is a port of the Talkie library to the ESP32. It's originally an Arduino library, but it's super fun to play around with. It sounds so much like a Speak and Spell, and I think it's actually because they use the original Speak and Spell ROMs and do the same kind of linear predictive coding speech synthesis with it. And it's just uncanny if you have played with a speak and spell how exactly it sounds like a speak and spell. But then it's got these crazy different vocabularies that they've pulled up from not just the speak and spell. So you've got some kind of normal words, but then a whole bunch of like flight simulators and things like this. So, among things you can have the Talkie library say is flaps are up, or you're running out of gas, or something like that. Red alert is lovely to hear in that kind of like 1970s speech synthesis voice.
Well, you can pretend you're on Battlestar Galactica, right?
Exactly.
Or let's say by your command, maybe, I don't know.
Ooh, that would be good.
I don't know. The ones you were saying, I was thinking would not have been good coming out of a speak and spell, right?
Right.
Your flaps up, you're out of gas. I don't know. It's not.
That's super simple to implement speech into your project using this library, actually. Like, it really is as easy as just put the pins out to a speaker if the thing can give out enough current, and otherwise, buffer it with a transistor and put it out to a speaker. Like, it's no work here, and you can add talking to your microcontroller project as long as you're willing to tolerate this, retro goofy talking.
And I do think the threshold has really shifted on that. Voice models now have gotten super good. So, of course, anytime you do see Star Trek or Battlestar Galactica, and you've got the tinny, weird computer voice, it's not aging very well, right? You think,
But for that, it has a certain charm, right?
Yes. Oh, yeah. Well, it's the retro charm. Absolutely.
Yeah. You're talking to a robot. Well, speaking of retro charm, a very slow movie player avoids e-ink ghosting with machine learning, blends kind of modern software with a neat idea that's not that old, but, at least a few years old. Matt Kelsey takes on the slow movie player project here. The first time we saw the very slow movie player, the idea is if you want to show a movie on e-ink, you don't have that high a refresh rate. And so you might as well take that to an extreme. Instead of showing 24 frames per second, you could instead show like 24 frames per hour and just run the movie really slowly. And the original project did this with 2001. This project takes that and runs with it. It's using a 1-bit dithering to put the image up onto an e-ink display. But Matt Kelsey took umbrage with the kind of flash that an e-ink display has to do when it wants to redraw pixels, right? It has to refresh them and set them all to white and black again, and then draw the image. And that kind of disturbed him with the aesthetic of the thing. And so instead, he set out to figure out a dithering algorithm for it that would dither the movie nicely, but also result in the fewest changes in pixels between frames to kind of minimize the need to do this like full frame refreshing. And then Matt took it one step too far. And that is, he brought neural networks into the question. And so he's doing the dithering with a neural network trained to do the dithering, but then also trained to do kind of a minimum number of flipped pixels from his previous frame. And he runs it through slowly that way. And it's a really neat idea. It runs into some obvious problems, like if there's a pan, a lot of the pixels are changing. And if there's a scene change, of course, all of the pixels have to change. And so how you deal with the logic of kind of minimum number of flipped pixels with then times where all the pixels have to change because you've done a cut scene, right, from one to another. For my taste, the just throwing neural networks at the problem seemed a little brute force to me. I think there's got to be some really super clever ways to like solve this constrained dithering problem. Part of me just loves the problem. I think it's really cool. On the other hand, he's got a working solution and is playing aliens on this thing. And so that also just by itself is really pretty cool. He points out in his to-do list here, though, that when you switch pixels on an e-ink display, the real problem that causes you to need to do this refreshing is going from a white frame to a black frame, but not the other way. If you go black to white, it goes fully white without needing a refresh step. It's only when you're going from white to black that you need the refresh step. and he suggests that he could like tweak his optimization to minimize the number of refresh steps, that is white to black transitions, but ignore the opposite side. And so even this is not as simple as you might think.
Yeah, this one was really cool. And, I couldn't help but think it's almost a gray code problem, right? You do a rotary encoder and you say, well, I don't want to change more than one bit at a time because, mechanics.
Right.
And that got me thinking even more. I thought, it's a very cool project, no doubt about it. But I wonder if you could have done the neural network with relays and then had like electromechanical displays, the old ones that flip like on a train. So you have 143 by 143 flip dots, and that's your screen. Relay logic to do all the dithering, and that would be a project, right? You could sell tickets for that, and the noise would be glorious, right?
The slow movie player is just a fantastic project, and it's one that I know a bunch of people have rebuilt on their own because it's just such a great idea. I know actually Mike Stitch, former editor-in-chief Mike Stitch, built himself one. Who else? Rich Hogben, who actually runs the kind of web backend over at Hackaday.io. He's built himself one. So like even just on immediate Hackaday staff, I know 2 people who've rebuilt this project. Man, if I had an e-ink display kicking around, I think I probably would too. It's just a really great idea. Maybe I'd do it with Dr. Strangelove.
Oh, there you go.
That's a really pretty movie.
You wish they'd come up with a different name, though, because it sounds like it's kind of like saying I adjusted the brightness on my TV, but I still got the same stupid programs, right? It's like, it's not a slow movie player. It's a slow movie player.
Right.
Well, my next one is Breaking Taps. It's got a very interesting machining channel. We were talking about I'm not very good in the machine shop, so I love watching that stuff. It's like watching pro golf. You can't do that, but you still like to watch it. The model that he made in this video was really interesting. It was about the space shuttle, part of the space shuttle engine. And, the title was something like how they did 3D printing in the 1970s, which of course you think, wait, did they do 3D printing in the 1970s? And the answer is not really. But I guess the combustion chamber, and I'm going to get the terms of this wrong, everybody can roast me in the comments, but the combustion chamber portion has to be cooled. And one of the techniques for doing that is to have the fuel run through and cool before it gets into the combustion chamber. So to do that, you need these little pipes. And I guess before the space shuttle, the way they did that is they brazed little bitty pipes all along the bell. And of course, every time you weld something that's going to be on a rocket, it's got to be X-rayed. It's got to be is a big deal. And I guess the thermal conductivity wasn't as good, so ideally, you wanted to build these channels into the bell, but there was no reasonable way to machine that shape with the tools that they had on hand. So what they did was very cool, and he did this on a smaller scale, is they went ahead and machined it where instead of tubes, they have channels on the outside of it. Then they fill those channels with wax. And of course, it's not, beeswax. It's some sort of industrial special wax. Made it conductive, and then they electroplated a layer or two of copper over that, and then nickel on top of that. So the nickel gave it some structure, and I guess nickel doesn't react well with, liquid hydrogen or whatever they were using there. So the copper kind of insulated it, and also, I'm sure was better for thermal conductivity. So they were able to put these very fine channels directly in the bell using this combination machining, electroplating, and then of course you flush the wax out afterwards, and you've got these beautiful little holes like that. So it was kind of an additive manufacturing. And I made the comment in the post about, this might have been one of the original additive technologies. But of course, in the comments, a lot of people were saying, well, what about, when I don't remember all of them, but there's all these old technologies where you are, in fact, building up something out of nothing. So I guess really that's not at least I didn't say it was the first. I said one of the first, but it certainly was something that we were doing before you really thought of additive manufacturing. That was sort of additive manufacturing. We've seen a couple of attempts to make metal 3D printers that use this electroplating technique even without the wax and the machined part. But of course, the problem is electroplating is slow. And you can see that in the video. So, yes, you can print with metal pretty easily if you're willing to electroplate. Just be prepared to wait a long time.
Yeah, I really like some of those projects though, where they do plastic as the substrate, right? And then you coat it with something conductive and then start electroplating on top of that. And that's just really cool because then, especially if you do it in some plastic that can be dissolved away, you can make these incredibly tiny little metallic shapes that you couldn't make otherwise, I guess, unless you have a metal 3D printer, which I don't. But, you can make these like fantastically intricate shapes and then have them actually be metal.
I'm always surprised we don't see more lost casting projects. I mean, we do see some, obviously, but that's an old technique, well understood, not nearly as noxious as electroplating, right? You do need some way to melt your metal, and you need the investment and the all that stuff. It's not trivial, but it's not as. It seems like that's a very easy way to get metal parts, and of course they make a lot of jewelry that way, and I think that has largely gone to 3D printing instead of carving them out of wax like they used to.
Yeah.
We don't see many projects on that.
That's funny. My grandfather was actually a jewelry designer. The thing he did for a living was he would make the wax figures and then he would make the bronze molds that then would cast them into whichever metal, silver or gold after the fact. And that was really cool. And so I grew up around lost wax procedure, and he did a lot of sculpting in this super hard ring wax that they have. Really fun stuff. It's a great procedure, and it's really simple. He did it all in his basement, actually. Like, he worked from home, his basement foundry. My next hack is an entry into the op amp contest. Still running, by the way. If you've got a cool analog project that uses an op amp, enter away. Head on over to Hackaday.io, click down for contests, and enter. Op amp contest entry, a slice of the 70s. And this is a crazy, possibly intentionally obtuse little op amp noisemaker by Burkhard Kainke, who has an absolutely phenomenal webpage, by the way. If you haven't been over to his website, it's just full of microcontroller projects for the last decade. I'm a secret fan of his and just totally chuffed that he entered something in the Op Amp Challenge over on Hackaday.io. But that aside, the triggered sound generator is a weird op amp based sound maker. It's weird in two ways. One, it's triggered by what? By basically whatever. It's got an LM358 op amp on the front end that amplifies some signal, and he has it hooked up to an LED and an antenna, and the LED is set up so that it's sensitive enough that if you shine light on it, it works like a photodiode and turns the trigger on. The antenna, if you touch it or even make electric sparks around it, is sensitive enough. So basically, he says that if you set the values just right, even if you walk into the room and you're slightly statically loaded with a long enough antenna, it'll pick you up. So what is this sound generator triggered by? Basically whatever. And then after that, the sound maker circuit is kind of also a little bit bizarre. It's basically a tuned filter that then the op amp amplifies a little bit. I don't know, those of you who are radio nerds, the op amp is run at unity gain, and so you'd think the filter would damp down the sound enough, but it actually has enough voltage gain at a particular frequency that it trades off voltage for current, and that's the sound this thing makes, whatever that resonant frequency is. It's the strangest oscillator design. And he does say that if you look at the circuit and you say, that could never work, my goal has been achieved.
That's every circuit I look at.
Yeah, right? Well, I hear you.
The op amps are fascinating, and I think it's, the FET front end ones like that, they have extraordinarily high input impedance. And so that's what makes this work, I think, at the base of it. If you think about it, and I've always been fascinated by this over my career, there was a time when it was really important that you knew how to say, well, I'm going to get these discrete transistors and build an amplifier out of it. But why would you do that now, right? Unless you need something super exotic,
right?
The op amp is going to be 50 times better than anything you can afford to actually do yourself anymore. So when you think about the quality of the amplifiers you can get for, pennies, that take up no space whatsoever, it's pretty amazing. Now that you mentioned the op amp contest, though, that reminded me we should talk about the Ask Hackaday where we asked for help on bipolar voltages for op amps. What did you make of all those comments?
Oh, yeah, let's pick that up real quick. I thought there were some really super helpful ones there. In particular, a bunch of people who were mentioning the kind of bipolar charge pump slash boost converter type circuits. Everybody had their favorite there. I think the one thing that I might have as a take home on this was I'm always super scared when I do designs with op amps about getting the power rails really clean. And dude writes in and says that most op amps these days have something like, quote, 120 dB supply side rejection on the output. So even if we've got a noisy power supply, maybe I'll be able to get away with it. And that is something that I'm going to have to just test out empirically. So we'll see what happens. But a whole bunch of other people recommended their favorite chips to do boost and charge pump and voltage inversion circuits and stuff like that. So I'm going to have to place myself a DigiKey order and get a bunch of parts in single, maybe 2 pieces each, because I usually burn one quantity and try some of these circuits out and see what works for us.
Don't you wish you had square brackets on the podcast? Because when you said dude said, I think that was the username, right? Not just
sorry, that is square brackets dude.
You sounded a little too hip there, Elliot.
Yeah, totally.
Well, it's one of my favorite things about being involved with Hackaday is just hearing all the different experiences and people's ideas. It's a great community.
And this article was basically a call for parts recommendations, and people did not disappoint.
So this week I've really been digging into the nostalgia pit, I think, but there was one from CellGen Studios where, and this never happens to me, he's in a thrift store and he finds this custom 1802 computer, and it's just gorgeous, right? Someone put an enormous amount of work in, and we don't know who it was. It had kind of the wooden keyboard side rails like you would see like on, say, one of the old, what was it, the Soul 20. It had a bent sheet metal case. It had a keyboard that was taken from some defunct word processor, oddly enough, that had been bought by Exxon and then axed. The company, not the word processor. It had an 1802, it had a bus, and it had, these connectors that looked like they were made out of like just regular dip pins or SIP pins rather. And somebody had gone through this enormous amount of effort, and there was a 1802 CPU card. I have a fondness for the 1802. That was the first computer I ever built, was around in 1802, and I can still assemble and disassemble its opcodes just with a piece of paper and a pen. Don't need any software, don't need any tables or books. Of course, if you know the opcode set for the 1802, that's not as hard as it sounds, but it's still just a sign of how much you love them. But it also had another card that was a video card. And so it had more memory on it than the CPU card. And then it just had all these other neat features. It had a little cassette interface that hooked up. He actually figured out that it was made to hook to a Commodore cassette deck. And so the idea that, I don't know what's more interesting, that it was this like, wow, somebody really put all this thought and effort into it, or how sad that it wound up in a thrift store, right? So
Yeah,
you can only speculate on why that was, but it's probably no good story behind that, right?
Yeah, it's just amazing to be walking through a thrift store and find a completely home-built, maybe even entirely home-designed computer. Did it say anywhere in the video if this was a design out of a magazine or anything?
Yeah, he couldn't find anything. And I'll be honest with you, my opinion, which is worth nothing, right? I have no knowledge of this at all, but it really looked to me like a couple of guys, or maybe, one or two people said, hey, this computer thing may take off. We should design something and sell it, right? And they just didn't get it to market in time. And then, if you look at the date code on the chips, the PC starts coming out and you're dead. But it really looked like somebody maybe saw a Soul 20 and thought, we could do that. We could make some money doing that. And then just didn't get it out in time. And that was the prototype. Yeah. Because, the removable boards, and there was bus space for more cards. Right. So obviously they were not planning on just, this is all we need. There were going to be more cards. There was a monitor and ROM, and I don't think he's been able to exercise it much because I think the keyboard is not wired still, and so he's got to reverse engineer the keyboard wiring. But the 1802 was real popular back then because it was very, very simple to get one of those running. It's static. It just needs a single supply, and it had a DMA mode that meant you really didn't need a ROM to operate it to start with, right? Now, in this case, you did because you needed to drive the video display, read the keyboard, all that sort of stuff. But just for a basic prototype, $100 worth of parts and a breadboard or some perf board, and you could get a system up. So I suspect it was somebody's attempt to storm the computer market, and it just did not work out for them.
Yeah, it does. It also looks really professional, right? Like it looks like a very nice looking prototype.
Yes, very much so.
This is the one you want to bring to your, investment panel or whatever, to your VC funding or whatever they did back in the 70s. Well, my first quick hack this week comes from TechMind's low-cost RF power sensor gets all the details right. This is a build of a design by DL5NEG, which is basically a Schottky diode and some resistors. But the devil is, of course, in the details, and TechMinds goes through all of the prototyping and testing here and gets it right. Watch this video if you feel like you need to make yourself a low-cost radio frequency power meter that works up to few gigahertz, 5 gigahertz, 6 gigahertz. Pretty impressive build. Next up, messing with a cassette player never sounded so good. This is an art/music project by Lara Grant. It's basically PWMing a cassette player and running that into an echo. And the demo in the video is using a tape loop of her laughing maniacally and speeding it up and down and echoing it and distorting it. It's really looks like a lot of fun. Last up, build some stuff. $60 robot arm is compact. This is a really sweet 3D printed robot arm design. It's cheap because it uses a lot of simple servo motors, which do kind of make it a little bit jerky. This is like definitely an awesome my first robot arm. But what really sells this one is the controller he built, which is a smaller version of the same arm, except using potentiometers in all the joints and a little bit of software to make the bigger version of it mimic exactly what you're doing on the little controller. That's just such a sweet little touch.
Yeah, it reminded me of the old Celsons you used to see in equipment, back in the 40s and 50s, or synchros, or whatever you wanted to call them. So. Okay, my quick hacks, a little bit all over the board this week. Ex-hacker USTC had the run Linux by emulating RISC-V on a RISC-V microcontroller, which seems a little odd, but I guess the RISC-V has different profiles, and so you don't have enough on the chip he wanted to use to emulate Linux. So he emulated a fuller set of RISC-V, which then he was able to run Linux on. They said the performance wasn't as bad as you would think, but you'd think it was pretty bad. So my guess is it's still not very good. But still, what an accomplishment. So Andrea Console had the half crystal radio, half regen radio. And, I got a soft spot for crystal radios. A lot of us, that's your first thing you build. And I always think, well, when the AM radio bands finally just drop dead, which is, the writing's on the wall, it's coming. What do the kids do then, right? What's your first project when there's nothing to listen to on the AM radio bands? And another radio project from LA6NCA are these beautiful little tiny spy radios that use tubes. And he's got a tiny 3-tube receiver to round out the station. And they're built on what looks like sardine tins. And if you're old enough to remember, QST had like the tuna tin sender, which was the Morse code transmitter built on a tuna can, kind of predating the Altoids build crazes. And I just thought that was very nostalgic, very cool, and very artistic. So those are my 3 picks.
All right, that brings us to the Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. And this week, I wanted to pick Joshua Vasquez's The B-Sides, More Curious Uses of Off-the-Shelf Parts. Josh is kind of our resident clever mechanical engineering design hacker. And in this article, he points out a number of hacks that you may not have known about. And he wrote a previous one like this. You should also go check that one out. In this version, there's a couple neat hacks using O-rings to hold things together. And the one that he features here is for a tool changer head on a 3D printer. And he slides it onto a metal rail and the O-rings here are used as little compression wheels or something to hold the carriage onto the metal rod without it slipping, even if the rest of the printer is vibrating along. He mentions that it's a challenging print and you have to get the sizes just right, but he mentions also that if you don't, you can either fix things up by choosing neoprene versus silicone O-rings and or add grease to make it a little bit slidier if you don't need so much stiction. I think it's a really cute hack and a great use for O-rings kind of as little, I don't know what, stopper or holder tires. He also mentions some DIY thrust bearings of his, although he ends that one with, this is kind of a hack, but it's a good thing to have in your back pocket when you need it. Another one that was actually really interesting to me, just because I had never seen these, were some chip-on-board LED strips that instead of firing straight out of the surface, they're side-firing LEDs on the LED strip. I mean, I'd just never seen a side-emitting LED strip, but it makes a whole bunch of sense, because how often do you want to tape something down and have it shining up out of the tape? No, you want to put it on the edge of a bench or the edge of your, you want it to light down onto your desk. And to do that, a side-firing LED is kind of more what you want. Here he's using it for microscope illumination for a camera inspection tool. But again, that's a cool part to know exists and have in your back pocket.
Yeah, I always look forward to seeing something Josh was written. I mean, I probably shouldn't admit this to him, but if there's ever a need to build some sort of life support mechanism that's mechanical that my life depends on, I hope he's designed it, right? He's that's the highest flattery I know how to give somebody on that. So yeah, there's just a lot of interesting things. In links, I think it was a week ago, 2 weeks ago, there was a short video that Dan linked to about how to take calipers, and some guy that's a real hotshot machinist, I don't even know who it was, had, the calipers, and would show you how to measure things with the calipers. And you're like, oh, I've been using these wrong all this time, right? So there's all these tricks that these guys know, just like we probably know stuff about electronics that would surprise a lot of people, but doesn't surprise us. And so anytime people will share that stuff with us, I think it's enriching. And my pick this week was Arya's the FET, the Friendly Efficient Transistor. And I just thought that was such a great title. I think I picked that one just on the title alone. I loved it. I've always been a big believer the FETs are vastly under-respected. It depends on who you are, I guess. If you're designing on the chip, it's they're used a lot. But in discrete designs, there's a little bit of a mystique about it. And in reality, if you look at the history of them, they were trying to discover the FET when they discovered the bipolar transistor. So really, the FET was sort of the solid-state tube, if you will, and they just came to it later. Early FETs had a lot of problems, but just like we were talking about, the op amps have gotten better. Well, FETs have gotten a lot better too. And you've got the V-channel FETs and, lots of other things. So the idea that, well, if I use a FET, I can't get any power. They're going to be super sensitive. I'll blow them out. They're not, all those things are way in the past. And so I'm always surprised when you still see people using bipolar, unless it's just a super cheap or super stupid application. A lot of times a FET is much, much better. Even something simple like, say, triggering a relay, you say, oh, well, yeah, I'll do that with a 2N2222. Okay, but if you look at what a really reasonable FET will turn on at, the power you're dropping across that 2222 is way worse than what you'll drop across a good quality FET. They make FETs that have logic gate compatible gates now. And so I just thought that was a very timely article, as far as it's something we all ought to be probably using more, and you just don't think of it. There's all our old standards you go to, but the FETs are really a much better solution most of the time.
Yeah, if you need to move any power, like milliohms of on resistance is what you're looking for, and FETs are what give it to you. She starts off, though, with like one of my favorite circuits, and this is why you still might like BJTs if you have to do any design work, because the combo of a high side switch, so you've got a PFET that's used to turn your whole device on and off maybe, And a BJT, a regular old transistor, is absolutely unbeatable. And in her example here, she has the FET switching on and off a 5-volt power supply. But you can imagine that you want to turn on with the microcontroller a 12-volt power supply, or, for a motor, a 24-volt power supply or something like that. The trick with the PFET then is, how you interface these potentially way too high for your microcontroller inputs to the microcontroller itself. And that's where something kind of forgiving like a BJT stands in. And, this is what IGBTs are, right? They're it is that bipolar transistor and the FET in one package. And that's what makes them so fantastic to use. And here she is kind of breaking down in the very first diagram, I think the most fundamental / useful FET circuit you're ever going to have, because it is a little bit tricky if you're dealing with higher voltages to get the gate voltages that you have to put on the FET into where you can use them with microcontrollers. For those of you who aren't total transistor fans out there, with the BJT, they're basically current controlled devices. So you just need to be able to put a certain amount of current through it and then it turns on and off. Whereas FETs are voltage controlled devices. So you have to put the right voltage on it. But that voltage then has to be referenced to either the top power rail or the bottom power rail. And there are times when producing these voltages are just super inconvenient for a microcontroller. Whereas at the same time, you can always find some way to have a microcontroller squeeze out a little bit of current and turn on a BJT. And that's why this combination circuit is absolutely the hottest thing since sliced bread. And I use them all the time, even though it looks on paper more complicated. Because, you got 2 transistors instead of 1. You get the benefits of the easy-to-useness, which is not a word, of the BJT and the super low on resistance of the FET.
I used a similar circuit back in the 1980s for an EEPROM programmer where you had to switch potentially either bidirectionally or a low voltage or a high voltage. And so it was a little different than that, but it was the same kind of idea. And it did use a bipolar and a FET. But the nice thing about the FET, it is a voltage controlled device, but because of that, you don't have to have, you can have virtually no current, right? The gate's pretty much an open circuit. So there's a place for everything, right? There's a place for all tools, but I do think the FET is tragically underused, especially in non-power applications. Some of the JFET stuff, for example, can be used as a variable capacitor, or you can use them as a variable resistor in a lot of cases. And it's just, a lot of times we don't see those kind of elegant designs, and you see a lot more work being jumped through to get it to do with bipolar or some IC that's maybe overkill. Maybe the article will spur some more people to work with FETs.
That wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you want to follow along with the links, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, send us an email at the tips line, tips@hackaday.com. And until next week,
be sure to keep the hacks coming. An Alexa at her place. Oh, and there goes Alexa. We'll have to edit that out. Sorry.
Probably won't include that.
Well, I was going to say, or, sell a trunk full of cocaine, but you probably don't want to put that one in either. So there you go.
Why don't I write these down when I take the notes? That is lovely. Talking FETs, facts, and electrochemical.
That might backfire on you.
Super.
Oh, you know me, always at a loss for words.